Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, so this is a video for lecture about combinations. Okay, so let's first look at the definition or the meaning for combination. So combination is a set of items that has no consideration given to the order or arrangement of the items. So different from permutation that really focus on the arrangement, but for combinations, no consideration given to the arrangement, but just focus on the item selected. Okay, for combination, arrangement of P, Q, R, P, R, Q, Q, P, R, Q, R, P, R, P, Q, and R, Q, P are still considered as one. Okay, so the formula for combination is NCR, where NCR is equal to N factorial over R factorial N minus R factorial, and the R must be less or equal to N. Okay, so let's say we want to find the number of combinations for 3 letters that are P, Q, and R taken 2 at a time. Okay, so we have 3 items. So 3 items mean 3 C and 2 at a time. Okay, how do we know it is a C? Because I already mentioned kan, combination. Tapi if the question doesn't mention any about arrangement, okay, so it can be a combination. So 3C2 is equal to 3 factorial over 2 factorial 3 minus 2 factorial, and that is equal to 3. Okay, so let's try this example. There are 5 students. Find the number of ways to choose 2 students. So 5 students represent the items. So we have 5C, and there are 2 students, so 5C2. So we have 10 ways. Okay, then for question B, a president and a secretary. So a president and a secretary means we have a slot for president and another slot for secretary. Okay, so in order to choose the presidents, we have a total number of items that are 5. So 5C1 for president multiply with 4C1 for secretary. Okay, notice here that for secretary we use 4 because one of the students is already selected for president. So then the number of students that can be choose for secretary has been reduced to 4. So by this way we have answer for the answer is 20 ways. Okay, the next example is a committee is to be formed from 8 men and 4 women. Find the number of ways this committee can be formed consisting of 7 members. So consisting of 7 members, so we have a total of 12 items, 8 from from men and another 4 from women, and total we have 12 items selected for combination into 7 slots. So that will be 12 factorial over 7 factorial multiply 12 minus 7 factorial. So we have 792 ways. Okay, then for question B, 5 men and 2 women. So 5 for men and another 2 for women. So 8 from the total number of men will be computed for 5 position for men multiply 4 total number of women combination for 2 position for women. So we have 56 times 6, that is equal to 336 ways. Okay, then C, 7 members with the men more than women. Okay, since we want men more than women, it could be all of the 7 members are men. So when all of the 7 members are men, so that will be 8C7 selected from the total number of items of men. So we have here equal to 8. Okay, so the next thing that could happen, the committee could consist 6 men and 1 women. So this is still correct based on the situation, based on the condition where the number of men is more than women, but there are still total of 7 members. Okay, so for this one, it will be 8C6 multiply 4C1. So we have 1, 1, 2. Okay, then next we could have 5 men and 2 women. Okay, still following the condition. So 8C5 multiply 4C2. So then we have 3, 3, 6. And another situation where 4 men and 3 women. So equal to 8C4 multiply 4C3. So that is equal to 280. So the total number of ways where the 7 committee has more men than women will be 8 plus 112 plus 336 plus 280. So total we have 736 ways. Okay, next example is in a test, a candidate is required to answer 8 out of 10 questions. Find the number of ways a candidate can answer the question. Okay, so we have 10 questions that 8 must be answered. So that is just 10C8. So equal to 45 ways. Okay, and then B can answer the questions if the first 3 questions must be answered. Okay, so the first 3 questions must be answered. So from the total 10 questions, so the first three questions are already answered. So we are just left with another 7 questions. So since 3 are already answered, means we have another 5 that is required to be answered. So that will be just 7C5 and equal to 21 ways. Alright, so next question is 7 points are marked on a piece of paper with no 3 points forming a straight line. Find the number of straight line that can be drawn. So that means we have 7 points, 1, 2, 3, 4, 5, 6 and 7. And find the number of straight line that can be drawn when no 3 points forming a straight line. Okay, the meaning here is we have 7 points. So we want to form a straight line by only using 2 points. Okay, we are not allowed to form a straight line by using 3 points. Okay, for example, I show you this is a straight line that is using 3 points. Then the question 1, the straight line that is only using 2 points. So the straight line could be here. So okay, this is 2 points, or here, this one, or this one, or this one. So it could be in many ways. So in order to calculate the total number of line, we could use the 7 from the total number of points that we have, C2. 2 is the number of points that is required to draw the straight line. So 7C2 is equal to 21. So there are 21 ways to draw a straight line by using only 2 points. Okay. So for question B, triangle that can be drawn. So in order to draw a triangle, 3 points are required. So to draw triangle from the 7 points, it must be 7C3. So we have 35 ways to draw triangle from the 7 points. In many ways, can a teacher choose one or more students as prefects from 5 eligible students? Okay, so teacher choose one or more student. So there it could be only one prefect, it could be 2 prefect, or it could be 3 prefect, 4 or 5 prefect. Okay, then it means it will be 5C1 in order to form only one prefect, or it could be 5C2 in order to choose for 2 prefect, 5C3 if we want to choose for 3 prefect, 5C4 for 4 prefect, or 5C5 for 5 prefects. So we total this up, so that will be 5 equal to 10 equal to 10 equal to 5 equal to 1. So we total that up, we have equal to 31 ways to form a prefect from 5 students. Okay, so let's discuss an example from the reference book. Example 6.1, page 1 to 5. Okay, so let's say a committee of 5% is to be formed from 10% consisting of 4 boys. So we have 4 boys and 4 girls, 1 male teacher and 1 female teacher. You find the number of ways to form the committee if the committee must include both teachers. Okay, so from the 5% for the committee, 2 are already occupied by the teachers. So that means all of the teachers are already selected into the committee. So we have another 3 blank spots for students. So we have total number of 8 students. combination into 3 spots, so 8C3, so we have 56 ways. Okay, then for B, the committee must have at least 3 males. Okay, so in order to have 3 male, so let's say 3 male are selected and another 2 must be a female. So from the persons that we have, so boy is a male and 1 male teacher is also a male. So total we have 5 male and we have another 5 female. So for 3 male and 2 female, so that will be 5C3 multiply 5C2. So that is equal to 100. Okay, but the conditions mention that must have at least 3 male. So there could also be 4 male and 1 female. So for that one, 5C4 multiply 5C1. So this one is equal to 25. And we could also have all of the committee members are male. So for 5 male, so that will be 5C5, that is equal to 1. So we have a total of 126 ways where the committee must have at least 3 males. Okay, then for question C, the committee must include the male teachers, 2 boy and 2 female. Okay, so since we want 1 male teacher, another 2 are boys and another 2 are female. So this one means for the boys, we have to select 2 boys from 5 boys, so that from 4 boys, so that will be 4C2 multiply, this one is female, so female includes the teacher, so that will be 5 female C2, so equal to 60 ways.